Good afternoon all. I've got a couple of items of post that I want to open, but I don't really want to do a full post bag. These two items of post are related to one particular thing that I want to kind of work on. So I thought I'd do a sort of post bag plus. Right, so this one is electronic parts. I think I can feel what it is, and it should be related to the item that I want to work on. Yes, it's surface mount devices. Specifically, surface mount LEDs, and I got the big ones. I got the 1206, and these are in blue. So let's get a couple of these out. Now, how am I going to light these up? With a 3-volt lithium coin cell? It might work. So there's a little arrow on the bottom of there. Now, is that the arrow, the sort of diode arrow? So that would be cathode, that would go to negative. So is that going to go like that? I'm going to have to short that across there. Oh yes, that's it. So that diode lights up. Cool. So the reason I bought these surface mount diodes is for this. It's the 6 supercapacitor module, and I soldered blue LEDs across these resistors, but if I close in, it should be possible to solder the LED kind of across there, The LED goes across the resistor. So if I scrape the corner of that and scrape that, I can solder the LED on there. Then the LEDs will be sort of nice and neat on this PCB. It's got a bit dusty. And I wouldn't have to have them sticking out the sides. I could actually take those off. But it would probably still work actually if I had both LEDs on. So I'll probably solder the new ones on, make sure they all work, and then start taking these ones off. You'll notice that I've added on here a little voltmeter, which is a digital voltmeter. The problem with this is that it only shows the voltage of this module down to about, I think it's 4 volts, and then this thing sort of packs up. So I'll probably take that back off again. So these items are 1206. Now, I think the 12 is 1.2 tenths of an inch, or 12 hundredths of an inch, or 120 thou, I suppose you could say. 06, so it's half that dimension in the other dimension across the width. Surface mount device, surface mount transistor, is that? SMT, is that surface mount transistor? Anyway, it's not a transistor, it's a diode. LED, red, green, blue, yellow, white, 5 colors, light, super bright LED. Now, I don't know whether you can see the contents of these selection boxes, but I chose blue, 100 pieces, so the price is $1.92. Free shipping, and these came from Alice 110 1983. I have no affiliation with Alice. I just buy a lot of stuff from Alice and also CZB 67219. I can't remember what it is, but the other one. I can see on here that these don't have the little arrows that mine have on them. This has a slightly different marking, but there we are. The arrow does appear to be quite useful in identifying the anode and cathode. And so the next one, I hope it's what I think it is. Oh, and that there is a little bit of a clue. These are, well, that one's very bent. Well, let's open them and find out. And they are analog voltmeters. So I thought it'd be quite fun to put a big, they are big actually, these are very big, a big analog voltmeter on here instead of this digital voltmeter, because this will read volts all the way down to 0. I'm also hoping that this will draw less current than this LED one does, because with the LED one on there, it does actually drain it quite quickly. So I'm just hoping that this will drain it very, very slowly, and I can watch it go from, I picked 20 volts full scale deflection FSD, I think it is, deliberately, because this goes up to about 17, 16 and a half, that sort of thing. So we'll see that on there, and I'm hoping that that will work its way down very slowly. Right, there's also a little bag of nuts which go on those two screw terminals. Oh wow, that is very long, isn't it? Let's take that out of its bag. I've got to work out a way of mounting this. Do you know, it's almost worth mounting it that way round so that the screw terminals go down onto the positive and negative end points, and then I'll actually read it from the other side. I really want it angled up a bit, don't I? Yeah, so that looks like it'll be fine. This one's got a bit bent. Is it destroyed? Hopefully not. No, that one's fine. And there are mounting points there as well, which I probably won't use. I'll probably mount it actually on the connection terminals and use that as the sort of anchoring point. Yeah, I think those will look quite nice. Very retro. Oh, I've just noticed that this one is a little bit smashed. I suppose that's just... I mean, the point is the seller can't be held responsible for something getting damaged in transit. These were reasonably well packed. I think I'll just have to live with it. Right, so the meters are these. They're white DC 0 to 20 volts. 85C1-V, not sure what that is. Class 2.5, I don't know what class 2.5 is, but you can see that it says class 2.5 on the right hand side and 85C1-V on the left, so I'm not sure what these things mean. Voltmeter, analog volt panel meter, new. I bought 2 of these, but they look like they're $2.73 each, free shipping, and these came from Lucky Warm. So now what I'm going to do is fit 6 of these LEDs onto this module. I have actually ordered another one of these modules because I want 2 of these side by side with their voltmeters for an experiment for my Muppet 2 project. But the first thing I'm going to do is probably scrape the solder resist, all this coating stuff, off this PCB to expose the copper and try and solder those little LEDs on, and then I'm going to attempt to mount one of those panel meters on here. Probably what I should do first is just brush the dust off here. It has got very dusty, just need to be sort of slightly cautious of static generated by this sort of activity, but I don't think there's a lot to get damaged on here. Right, so just warming the soldering iron up. Now the metalwork in there is also slightly pointy, so I can still identify the cathode. It's on the left there, and the LED that's already on there has its flat on the left, so that's the cathode. So my LED is the right way around. I just now need to solder it onto that bare copper. So let's use these heat resistant tweezers to put my component into position. There we are. That's good enough. So now I'm going to solder it, but what do I do to stop it moving? Perhaps just press down with the tweezers or something. Do you know what? I think I'll use my old friend Blue Tack. Just a little pellet of Blue Tack. There we are, that should hold it in place. And now I'll solder it. Now I always get criticised for the way I solder surface mounts, so frankly I don't care. Get some solder on there. Oh, it's tombstoned! Damn it! Okay, well on this occasion then the criticism is entirely valid. Oh, that's still loose. So I think I'll just hold it down. Maybe if I pre-tin these areas of copper, perhaps I'll do that. I need to get a fairly light coating of copper on, of solder on there. I don't want too much. It's not taking solder very well. Flux would be my friend here, I'm sure. Why's this iron gone cold? You just wait till you get to 50 and your eyesight starts to fail. You'll have all these problems as well. Right, I think the issue I'm having here is I'm trying to solder onto these large expanses of copper, and they're sucking the heat out of the iron. Oh god, it was much easier in the old days of through-hole components. It really was. These things are so fiddly. Right, this is the wrong soldering iron. It's not temperature controlled. It has got a bit hotter now because it's been on for a bit longer. No need to tell me that I'm using the wrong iron and I need a temperature controlled one. That's fine, I understand that. Probably actually this would be better done with solder paste and a hot air gun rather than actually attempting to solder it. I found that I'm getting on better putting the LED on at a jaunty angle so that only the tips of the LED are actually touching these copper pads. These copper pads are very large and they're sucking all the heat out of my soldering iron. Yes, I'm having a few problems, but I'm going to finish this. Right, I soldered the rest of those off camera. This is, after all, not a soldering tutorial. This is just me having a few problems. I solved those problems, mainly by soldering the surface mount devices at an angle. That seemed to make it a bit easier for me. I'll get in a bit closer so you can just have a look at the result. And there it is. Yes, the LED is soldered at an angle, but it is at least anchored on there. Now, to test it and see if it works. Right, this plug arrangement here is designed to plug neatly into the Ruideng DPH unit. DPH, I can't remember the numbers. 5015 is it, or something like that? Let's have a quick look. The DPH, 3205. So this is the buck boost, which means that my incoming 12 volts can be boosted up to 16, 17, 18, whatever I need to charge this thing fully up. Let's see if my blue LEDs work. Yeah, packing this thing away each time is all very neat and everything, but it is a bit of a nuisance when you've got to completely reassemble this thing. So we've got the LCD cable there. We've got the what's the other one? Yes, the key cable there. Let's press that in. Quite tight, these cables. Right, so they now have to be connected to this thing. LCD is that one. Let's bring this up. Where's LCD? So that's there. Plug that in. These, I presume, will loosen up over time, so they're not quite so hard to plug in. Right, that's everything done. I've also got that in the box ready made up, so that's quite handy. That's ready to have my 12 volts plugged in, and then that thing should power up. Might as well do it now. Yeah, that's all good. So that's set for 16.6 at half an amp. We can now start charging this thing up. So let's plug that straight in and get charging, which I think just means switching it on. 16.6, half an amp. So that's going to take a little while. I'll let that, actually I could raise that current a bit, but that's climbing up. I'll let that climb up and we'll see whether these LEDs come on. Right, I got bored with that. It was going too slow. So I pressed the A button, which lights up the amps field. You click this thing to bring it up to that digit, and now I can increase it. So let's take it to 1.5 amps. Oh, let's go up to 2 amps. What the heck? So we'll get this thing charged up. Once it hits about 16 volts, we should start getting some of these LEDs coming on. Right, we're getting close. 13.5 volts. What I can do is go back to selecting amps, get back onto that digit, and as I approach 16 volts, I can start winding the current back down. We'll keep it on 2 amps just for the moment. 15 volts. Should start getting some of those LEDs. I broke one of them. That one's come loose, so that one won't come on. Right, let's start winding that back down. 1.5 volts. Should start seeing some activity now at 16 volts. We have got that diode drop, so that will drop a little bit. Oh, that's going quite high now. Let's take this down to 1 amp. So 16.5 is probably about 16.2 or 3 on there. Waiting for some of those LEDs to come on. Go down to 0.5 amp now. In your own time. Well, that's not increasing in voltage. That's interesting. Have we gone into, we're still in constant voltage. So what's stopping that rising? Let's take the current up a little bit. Got a very low current going to that. Oh, constant voltage. Ah, okay. So it's limiting at 16.6. So probably what I need to do is switch over to volts. Let's take that up to 16.7, 16.8, and they're coming on. Oh, and they're working. This is good. So 3 of them are working. So I can take off the old external LEDs. That was working. As I said, I broke that LED off. I could probably get that to work if I play with it. So that's 4 of the 6 have all lit up. I mean, this is good. I'm happy. Just this one and this one to go. Probably have to leave it for a while because as these capacitors discharge, then... Oh, I've got 5 on now. So just this one remaining to light up. I'm sure that will come on in the fullness of time. I'll probably have to edit this bit out where I'm rambling. There we go. Look, all 6 LEDs are on. They're all working. So now I can take off the external blue LEDs because I've got my internal ones. Awesome. Right, these are all on. I should give them a chance, I suppose, to back off a bit. So I'll just switch that off. And of course they start switching off as the capacitors start discharging. All good. Right, I'm going to take all these external LEDs off and start thinking about a voltmeter. Right, taking these external LEDs off should be much less of a hassle. So I could see what I was doing. There we are. So I'm going to remove all those, just tidy the solder mess up, and I will have the internal ones from now on. Right, now here's a piece of good luck. Look at this. This voltmeter, I want it that way round, but of course one of these terminals is going to be positive and one negative. We can see that positive is the diode side, well, you can see it from there as well. So positive is that side there. Is that indeed positive on here? Yes, it is. 3 volts. So that can go that way round. I need the nuts and bolts that came with these meters and some spade terminals or ring terminals and some little bits of wire, which I'm going to put down these outer holes and then mount that on there, angled up suitably so that I can see both it and also get an idea of when these LEDs are coming on. I may not be able to see them very easily individually, but it'll be enough to tell me what's going on. Of course, I'll be able to see the voltage as well on the voltmeter. Now, should I go for spade terminals? Because these would be easier to get on and off. Although I've noticed that the ring terminals actually have a smaller diameter hole. So perhaps I'll go with the ring terminals just because of the smaller diameter hole. Yep, decision made. Right, a couple of nuts on there. Let's put some flat washers on there too. Then let's put the ring terminals on. Oh, they're a bit big actually. Okay, they're not quite the right size. Then I'll put a spring washer on. And finally another nut, although I seem to have run out of post a bit. It should fit. Now I've got some spanners for these little nuts. So I think they're either 5mm or 5.5mm. Let's see if I can find those. Right, nut stacks and washers and things all assembled. Look at this dinky little thing, that's quite neat, isn't it? 5.5mm and 5, actually it's the large end I think. I think these are 5.5mm across the flats, these M3 nuts, so I'll just tighten that down against the spring washer. Put a little angle on these two so they'll angle out onto the 2 outer points here. So let's just tighten those up. Right, those are fitted on there, and I've got some diode cut-offs here from when I was making the charge controller, so 2 of those might just be long enough to come out of here and go into there. So what I'll do is I'll just feed these into these ring terminals. I need to hold them in somehow. I'm going to solder them, but just to hold them in temporarily, I might just crimp that. And by crimp, of course, I mean just use cutters to sort of plier that in, so that's not going to go anywhere. Now I'll solder that and do the other one. Right, so I want that to kind of sit up a bit so that I can see it. So I'm going to have to do a little sort of three-dimensional bend of those to get them to go down straight through these holes. Let's give that a try. Yeah, that fits pretty well, I think. That sits up like that, so I'll stuff some blue tack in there and get these soldered. Right, solder this into there. That's going to take a while with this rather underpowered iron, but it will do it. It's getting hotter and hotter, this iron, as the afternoon progresses. Actually, it might have helped to pre-tin that. In fact, working the iron from the top might give me a gravity advantage. Flood solder onto there. I did empty these holes out. Oh yeah, that's soldered nicely. Let's do the other one. Yes, of course, I'd forgotten that it still has 14 volts in it. So it's a good job I didn't short anything while I was doing that. But yeah, that looks good, and that's holding its voltage really well. I don't really like the fact that each volt is 2 of these little small ticks, but anyway, 14 volts in there. So now I can plug that back into the power supply, this one here, get that back up to the 16.5 volts or so. Actually, I don't need that blue tack in there now, that will hold itself, and just see whether that sort of is reasonably accurate. 16.5 volts. Let's plug the power supply back in. Right, that's the supercapacitor module plugged back into this power supply. So let's angle that around so that we can see it reasonably well. That's set to 0.5 amp, so let's start pushing that back up. Now, is that needle moving? Yes, it is. Well, you'd expect it to, wouldn't you? So now what I want to do is see these LEDs come back on. Okay, current. Let's go to that one. Go up to 0.6, 0.7, 0.8. Just give it a bit of a boost. 1 amp. We're looking for about 16.5, I guess. My voltage regulation there is 16.8. The meter's not actually quite square on, is it? So we're over 16 now. Let's bring that back to something that these discharge circuits can handle. If I set the current here too high, these discharge circuits won't be able to discharge. Oh, it's in voltage limiting. Do I need to take the voltage a tiny bit higher? Perhaps I'll go up to 16.9. Okay, there it is. Back to current, back to 0.5 amp. The discharge circuits are now starting to come on. Oh, they're nice and bright, these surface mount LEDs, aren't they? And what are we reading on the meter? Well, I reckon that's 16.5 because it's 15 plus 3 divisions. Yeah, 16.5 volts. And all of the discharge circuits are starting to come on. Now, the question is, when I turn that off, oh, these discharge circuits are still on, so that will drop fairly quickly until all these LEDs go out. That should happen fairly quickly. And that's all of them out. Now, how long will it sit there on about 16.25 volts? How long will it take for that to go all the way back down to 0? I'm hoping a very long time. Right, that's dropped to round about, if I can get the parallax right, 16 volts. So we've got 16 volts on there, and it's just gone 4 o'clock. I'll give it a while and see how quickly that falls. Also, of course, it would be a very good idea to see how accurate this 16 volts is. That's almost exactly 16 on there. Let's see what my DVM says. I'm not in amps, am I? I don't want to short this thing out and have a very loud bang. Okay, well, that's pretty good. 16.13, so the meter's reading, well, a tiny bit low. I mean, it depends on how you adjust it for parallax, but I'm happy with that. 16 volts on the meter, 16.1 on my digital voltmeter. Right, let's give it half an hour or so. Right, okay, not quite an hour has elapsed, and not quite a volt has come out of these supercapacitors. So I'm really happy with that. If that falls at a rate of about 1 volt per hour, well then that's absolutely plenty, such that the thing doesn't just sort of whiz to the bottom while I'm actually trying to make a video. So that's absolutely fine. And it's just occurred to me that this meter probably uses more, what would it be? Energy, power in watts when it's at a greater deflection than when it's at a lesser deflection. So if it's 1 volt per hour, then there's probably far more than 15 hours left, because as that meter drops down, it's probably going to be using less power. So it's a sort of non-linear fall. So it'd be very interesting to see where that is in, say, 24 hours time. So yeah, I'm really happy with that. There's something rather nice, isn't there, about these old analog meters. I mean, this thing is not drawing power to light up LEDs like that thing did. This thing conked out after a couple of hours. This is going to sit there for, well, could be in excess of a day. I really like that. So when the second one of these supercapacitor banks turns up, then I'll fit some more of these dreadful surface mount LEDs and the other voltmeter. And, you know, if you're like me and you absolutely hate surface mount components, could you let me know in the comments, because I don't really want to feel like I'm completely alone. Cheerio.